All right, last examples. So solving multi-step equations, this time I'm looking at combining like terms. So we're in another gum story. You've actually seen this one before. If you get a keen memory, you'll remember seeing part of this. It was not an equation at that time, but Mariah's friends thought it'd be funny if everyone gave her gum for her birthday. Her sister gave her 7 packs right here. Her dad gave her 4 packs right there. And all together, the rest of her friends gave her 31 pieces of gum. Okay, in total, between all the packs and the sticks, she's got 163 pieces of gum all together there. So we're finding out how many sticks in each pack. So I'm going to use an X to represent the number of sticks in a pack. Uh, does she, for any reason, need to keep track of 7 packs coming from her sister and keep those separate from the 4 packs that came from her dad? Not in terms of what we're after in this problem, where we just want to find out how many sticks are in a pack, right? A pack is a pack. They're all identical, whether it came from this person, that person, whatever. So I can just put the 7 packs and the 4 packs all together, right? And add them up. That's 11 packs, right? So that is actually what I'm going to do as my first step. I'm going to combine like terms. So I got 7x's here plus another 4x's here. Combining like terms means find the x's and put those together, find the constants or the numbers, put those together. You can do this as long as things are on the same side of the equal sign. So here's my equal sign. I'll just a highlighter right there. Okay, so everything currently that I'm working with is on the left side of the equal sign. A number that's on the opposite side, that's on the other side of the teeter-totter, I need that to stay over there to keep it balanced. I can't just like add the 31 and the 163 together. They're not on the same side of the teeter-totter. That'd be like saying, how many kids does it take to balance out the dad on the teeter-totter that's playing with his kids? Well, you can't say, well, there's dad on this side and there's a kid on that side. Let's add them together. That doesn't work. Doesn't work. Um, I've totally done that, by the way. I've gone on teeter-totter with my kids. They're way too big for that now. All right, so 7x plus 4x is 11x. The plus 31 is going to drop down to my next line. There's my line divider, and equals 163. Okay, working to try to get x by itself. I'm doing SADMEG, so multiplying by 11, adding 31. SADMEG says subtract or add first, so I'm going to get rid of this 31 in a different color. There it is. Technical slowness. Okay, and then let me do it on the other side. There we go. So adding 31, subtracting 31, those are opposites. They're going to cancel each other out. This 11x is going to drop down to my next line. 31s are gone. The equal sign comes down. 163 minus 31, that is 132. And my last step, I'm going to divide both sides by 11. However you want to write the divide, doesn't matter. Times 11 divided by 11 are opposites. They cancel. This x comes straight down. Equal sign comes straight down. I might scooch this together because it's pretty spaced out and that looks weird. And 132 divided by 11, that's 12. We can't bring the x over. All right, well, we're just going to leave it then. Creative pen. We need some flowers. Mariah loves flowers. Circle our final answer. X equals 12. 12 sticks per pack. Okay, so next up, we got another problem which is going to involve combining like terms, but also like everything else we have seen so far. So I also have distribution. I got some multiplication going on 3 times that set of parentheses. Okay, in previous examples where we've had distribution, I presented 2 options. In a problem like this, where I have other stuff going on outside of the parentheses, I don't have 2 options anymore. So I have this 7x plus the 3 times this group. Okay, since there are other parts of the number sentence outside of the parentheses, but still on the same side of the equal sign, I don't have those same options that I had before. Right, here's my equal sign. I was going to drop a division, like a barrier there to divide my workspace. Okay, so since there's more going on, it actually limits the number of options I have. So the first thing I need to do is distribute that 3 into the whole entire set of parentheses. So I'm going to take positive 3. So you could leave the plus behind if you want, but it's a positive number, right? So I'm going to take that positive 3. I'm going to multiply it onto the 2x. That was an arrow. And I'm going to multiply that 3 onto the negative 12. Okay, so the highlighted yellow 7x, I'm not going to do anything with that right now. So I'm just going to bring it down to my next line. It's going to wait for me there. Thinking ahead, I know a positive times a positive 3 times positive 2x is going to be a positive number. So I'm just going to put the plus sign there ahead of time. Let's follow the green arrow. I just said this, 3 times 2x is 6x. Let's follow the blue arrow. 3 times negative 12, negative 36. Equal sign right on that line, and the 42, I haven't done anything with that. It's going to stay put. Okay, distribution first. Now I have like terms that I can combine. I've got 7x's, I got 6x's over here. There's an addition sign between them, so I'm going to add those together. 7x plus 6x, 13x. This minus 36 drops down to my next line. Equal sign stays right on that barrier. 42 has not changed. Next up, I'm thinking SADMEG. There she is. There's SADMEG. She's sad because she's having a bad hair day. Man, I should have drawn that better. She's sad anyway. My bad drawing didn't help anything, but oh my gosh, your hair fell off. Wait, go back. Okay, leave her alone. The first thing I gotta do is it's supposed to be a circle. Wow, that is terrible. Okay, subtracting and adding. Pretend like I circled it instead of scribbling it out. So I'm going to, oh, where'd my pen go now? Technical difficulties. Do the opposite of subtract. You're going to add on both sides. You're going to add the 36. Minus 36 and plus 36 cancel each other out. 13x. 36's are gone. Equal sign comes down. 42 plus 36, that's what, 78? Last step, divide by 13 to do the opposite of this multiplication. 13 times x, I want to do the opposite, multiply. Right, divide by 13 on the other side. A little bit more workspace. 13's are gone. X equals 78 divided by 13. What's that? 6? X equals 6. Blam!